Okay, so the next question that we have is question number 6, which is basically some observations. You want to find the mean deviation about the mean of these observations. So these are basically your x sub i's, and then you have your f of i's as well. So your x sub i's are 10, 30, 50, 70, and 90. You have 10, 30, 50, 70, and 90. And then your f of i's are 4, 24, 28, 16, 8. 28, 16, and 8. Okay, so you want to find the mean deviation about the mean. The mean deviation about the mean is basically sigma f of I times the absolute value of x sub I minus x bar divided by sigma f of I, which is basically that is the mean deviation about the mean. So now first I need to calculate my x bar. So you know that your x bar using the direct method is equal to sigma x sub I times f of I over sigma f of I. So if I calculate x sub I times f of I, x sub I or basically f of I times x sub I, the same thing, doesn't really make any difference. So 10 times 4 is equal to 40. 10 times 4 is equal to 40, and 3 times 24 is equal to 60, 12, 720. 5 times 28 is equal to 100, 140. So that's 140, 1400. 7 times 16 is equal to what? 70 and 42. So that's 100, 112. And a 0, so you have 1120, and then that's 8 times n is equal to 72, 720. And so sigma f of I, sigma x of I f of I is all of these numbers added together, which is 760, 1400, 1120, and 720. So you get a 0 over here, you get 6 plus 4 is equal to 10, 1. And then you have 8 plus 4 is equal to 12, 13. 13 plus 7 is equal to 22. Then you get a 4 over here, so that's a 4000. That's a 4000 over sigma f of I. Your sigma f of I is equal to 428 plus 28 is 56, and then 16 plus 8 is equal to 24. So that's a 0, and then 1, 780, which is equal to basically these two you can cancel out. 5 times 8 is equal to 40, so that's a 50. 50 times 8 is equal to 400. Is equal to 400. Okay, so now that is the mean of the data. Now the next step is to find the absolute value of x sub I minus x bar, which is basically in this case equal to, for example, 10 minus 50 is equal to negative 40. In the absolute value becomes positive 40. 30 minus 50 is equal to negative 20, positive 20. That is a 0. 70 minus 50 is equal to 20. 9 minus is equal to 40. And then you have f of I times the absolute value of x of I minus x bar which is equal to 4 times 4 is equal to 160. 24 times 20 is equal to 480. That's a 0. That's 320. And that's 320, right? That's 320. So now you can calculate this as sigma f of I times the absolute value of x of I minus x bar. You have to add all of these numbers together. That's 640, 480, and 160. That's a 0, 14, 18, 1. And that's a 5, basically 4 plus 2 is equal to 6. That's a 12, 1280. That's sigma f of I, that's 1280. 1280 divided by sigma f of I, which is equal to 80. So you can simplify this as, first of all, you can simplify the 2 zeros and then divide by 2, you will get 64. Divide by 2, you get 4. Divide by 2, 32. Divide by 2, 2. Divide by 2, 16. And 1. So it seems that the mean deviation about the mean is 16, which is number 6 is 16 is the correct answer. Now we have some other data here, and here now this time we have the same kind of data, and we want to find the mean deviation about the median. The mean deviation about the median. So the data that we have is basically something like this. So you have your x of i's here, you have your f of i's here, and so it's 579, 10, 12, and 15. So, and the f of i's are 862, 226. 226. So, and what you want to find is the mean deviation about median, right? So what I need to do right now is find the median of the data first. So to find the median of the data, what you can do is you can use what you need to do is, you know that the median of the data is basically the observation that comes exactly in the middle of all of your observations, if your observations are sorted in an ascending order, right? Or in a descending order. So what that means is that now my observations have already been sorted in an ascending order. So the total number of all of the observations that I have is basically 14, 16, 18, 20, and 26. That means that sigma f of I is equal to 14, 16, 18, 20, 26. So when basically, and that is basically you can call it n, the number of observations. Now and this is an even number. When you get an even number here, it's like you have, for example, 1, 2, 3, and 4 observations here. So that basically there is really no observation that comes exactly between these 4 observations. Basically observations that you can find between these observations is actually 2 observations. So in such cases, what you need to do is that you need to take this observation and this observation, which you can find, as we discussed before, by n divided by 2th observation, and then divided by 2 plus 1th observation, and then take the average of these, and then the average of these two observations becomes the median of your observations. So now n divided by 2th observation is basically 26 divided by 2, which is equal to the 13th observation. And then the next one would be, of course, the 14th observation. Now, since you want to find the 13th and the 14th observations, it's not easy to, of course, it's in this case, it's not that hard to count, meaning that you can say, okay, so 8 plus 6 here goes all the way up to 14, and so 13 must be some observation in this, among these numbers, and these are all 7s, right? So your 13th observation is going to be a 7, and also your 14th observation is going to be the last number here, which is also a 7. So you get the 7 over here and you get the 7 over here, and the average of 2 7s is just a 7, right? So then your median is equal to 7. Your median is equal to 7. But of course, if you had more data, then of course you would have to find the cumulative frequency of all of those. We have already talked about that. You know how to do it. Now, the median is 7. So, then the formula for the mean deviation about the median, as you already know, the mean deviation about the median is equal to basically sigma of f of I times the absolute value of x of I minus the median, right? Because you're calculating the deviation from the median, it's about the median, and you divide that by sigma f of I because you want to find the mean deviation. You're taking the mean of all of those values. And so now what I need basically based on this formula is x of I minus m, the absolute value, of course, x of I minus m. So the x of i's are these and m is here. This is the value of your m. Let me write it properly. This is your m, the median. So 5 minus 7 is equal to negative 2. In the absolute value, it becomes positive 2. This is 0. This is 2. This is 3. And this is a 5. And this is an 8. And then you want to multiply f of I by this expression. So f of I times the absolute value of x of I minus m, which is equal to 16, 0, 4, 6, 10, and 6 times 8 is equal to 48. Okay. Now you can calculate the mean deviation about the median pretty easily, meaning that you have to just add all of these numbers together. It's sigma of all of these expressions. So 16 plus 4 is equal to 20, 30, 78. 78 plus 6 is equal to 14, 84. So that's 84 over sigma f of I, which is equal to 26, which is equal to basically divide by 242 divided by 213, and 42 divided by 13 is some value like, I don't know, 3 times 13 is equal to 39, and that's a 3, 0, 0, and then you have 2 times 13 is equal to 26, it's a 4, 0, 0, and then 3 times 13 is equal to 39. One remainder, and you just keep getting different remainders, I suppose. So it's 3.2, for example. It's 3.2. It's 3.2. So question number 7, the answer is 3.23, for example. You can take that as 3.23 as in the book, and we got the same answer. So this was question number 7. Now number 8. Number 8, we have again the same situation, some data over here, and you have your x of i's over here, you have your f of i's over here, 15, 21, 27, 15, 21, 27, 30 and 35. And then you have 3, 5, 6, 7 and 8. And then you want to find the mean deviation about the mean, right? And that is equal to the sigma of f of I times the absolute value of x of I minus m minus the deviant divided by sigma f of I. Now, so I need to find out what my median is. So again, to find out my median, I need to know how many observations I have in total, and then I have to go in the middle of those observations to find the observation that comes exactly in the middle of those observations. So to know that the exact number of all of my observations, I can calculate sigma f of I, which is equal to 8 plus 6 equal to 14. 14 plus 15 is equal to 29. It's an odd number. Whenever you get an odd number, the observation that comes in the middle is given by n plus 1 divided by 2th observation. Meaning that 29 plus 1 is equal to 30. 30 divided by 2 is the 15th observation. So now the 15th observation is basically 8. 8 plus 6 is equal to 14, and the 15th observation comes right in the beginning of these 30. So that's your number is a 30. So that means that your median is actually equal to 30 because it's the 15th observation. This is 8. 8 plus 14 plus 1 is equal to 15. That the 15th observation is a 30. So now that you know your median, you can calculate the absolute value of x of I minus m, which is equal to basically, for example, 15 minus 30, negative 15, positive 15 because of the absolute value, negative 9, positive 9, negative 3, positive 3 is 0, and 5. And then you can calculate f of I times the same thing, x of I minus m, and then you would get 45. 45 times 9 is equal to 45, right? 5 times 9 is equal to 45. 6 times 3 is equal to 18. This is 0 and this is 40. And then you can simply find the sum of all of these because you're calculating sigma of this. That's a 90, 130, 130, 140, 148 divided by sigma f of I, which is 29. And there is no good way to simplify this. So let's divide 148 divided by 29. Let's take it as 30 5 times 6 is equal to 150. 4 times 30 is equal to 120. So 4 times 9 is equal to 36, 3. 4 times 8, 11. So you get 2, 3. And then let's say that you have, there's something wrong actually. 5 times 29, what is 5 times 29? 45, 4, 10, 145. Okay, so I could have actually done 5 times that. So 5 times 29 is equal to 145. Is equal to 3 remainder, 0. 1 times 29 is 29. 1 remainder, 0, 0, 0. And then, I don't know, 0 over here, 0 over here, 3. So you can take it as 5.1. 5.1. So I suppose this was number 8, 15, 21, 27, 30. This was number 20. This was number 8. And the answer is 5.1. Okay. Now the next question that we have is number 9. Find the mean deviation above the mean for the data in exercise 9 and 10. The mean deviation above the mean. So let's say that you have this situation over here, and these situations are actually perfect for understanding the meaning of, for example, whatever it is that you're calculating. For example, the mean deviation above the mean, or whatever, or the mode, or whatever it is that you're calculating, because it gives you an actual situation. Okay, so the mean deviation above the mean for this data. So basically the data that you have is, I write them basically vertically. So you have income per day in rupees, income per day in rupees, and then you have basically and then you have number of persons, So for example, you have 0 to 100, you have 100 to 200, 100 to 200, 200 to 300, 300 to 400, 400 to 500, 500 to 600, 600 to 700, 700 to 800. Okay, and then the frequencies related to these are 4, 8, 9, 10, 4, 8, 9, and 10, and then you have 7, 5, 4, 3. And you want to find the mean deviation about the mean. The mean deviation about the mean, x bar, which is equal to sigma, basically f of I times the absolute value of x of I minus x bar over sigma f of I. So that means that I have to find the mean of the data first. So the mean of the data using the direct method is nothing but x bar is equal to sigma f of I x of I over sigma f of I. So that is equal to, now sigma f of I x of I, so this is your f of I. This is not your x of I, so you need first of all your x of I as well. So your x of I, we said that we had to find the class marks. We had to find the class marks which serves as our x of I, and you know why I'm saying this. So the average of 100 and 0 is 50, the average of 100 and 200 is 150, the average of 200 and 300 is 250, and then you can just keep going, 350, 450, 550, 650, and 750. And so these are your x of i's. As you can see, your x of i's are pretty large, but that's probably not a problem. You can probably, for example, use the, instead of this, use the for example, not the direct method, but for example not the step deviation method, but the other one, the assumed mean method, for example. Let's see how because if I want to calculate, for example, now x of I times f of I, what happens is that I have to calculate, for example, 8 times 150, 9 times 250, 10 times 350, and so on and so forth. These would be large numbers. So I take, for example, this number or this number, this one, as the assumed mean of the data as A. And then over here I can write d of I as x of I minus A, right? As x of I minus A. So now 50 minus 350 is equal to negative 300. Negative 300. And of course, let me see. The assumed mean method, in the assumed mean method, your x bar is equal to A plus sigma f of I d of I divided by sigma f of I, right? Well, okay. So now 50 minus 350 is negative 300. 150 minus 350 is equal to, 350 minus 150 is equal to 200, so that's negative 200. 250 minus 350 is negative 100. Here you have a 0. That's 100. 450 minus 350 is equal to 100. 550 minus 350 is 200. And then 650 minus 350 is 300. And 750 minus 350 is equal to 400. And still the numbers are large. So what I'm going to do is find some divide by d of I. Like I basically define some u of I as basically d of I divided by the class size, which is h. So the class size is here 100, of course. So that gives me negative 300 divided by 100 is negative 3, negative 2, negative 1, 0, 1, basically 2, 3, and 4. And in the step deviation method, your x bar is equal to basically A plus sigma f of I d u of I over sigma f of I, and the whole thing you have to multiply by h, the class size. So I need my f of I u of I. So now f of I u of I is equal to, now your f of I are these numbers and u of I are these numbers, so forth. That's negative 12, negative 16, negative 9, 0, 7, 10, 12, and 12. And well, sigma u of I, let me calculate this here, sigma f of I u of I is equal to, that's 20, 28, 28 plus 10 is equal to 38, 37, that's negative 37, and it's 24, 34, 34 plus 7 is equal to 41, so 41 minus 37 is equal to 4, is equal to 4, and sigma f of I is equal to sigma f of I is equal to 12, 12 plus 9 is equal to 12 plus 9 is equal to 21, 31, 38, 38, so I have 38 there, and this is 9 plus is equal to 12, 0, 1, and that's 50. That's equal to 50. So, so sigma f of I u of I, over here, sigma f of I u of I is equal to 4. And h is equal to 100. So I can write this as A, which is 350, plus basically sigma f of I u of I, which is equal to 4, divided by sigma f of I, which is equal to 50, and multiply this by 100, which is the class size. So I will get basically 2 times 4 is equal to 8, and this is 358. That is the mean of my data, 358. So that means that x bar is equal to 358. Okay, so now I can erase all of this. And the next step is to find the mean deviation about the mean. The mean deviation about the mean is simply basically this expression here. So I need to calculate the absolute value of x of I minus x bar. X of I minus x bar. So my x of I over here is 50 minus x bar is equal to 358, and here you have a 50, so you get 308. In the absolute value it becomes positive. Again, x of I minus x bar is 150 minus 358. 150 minus 358. So you get 358 minus 150 with a negative sign, 8, 0, and 208. That's negative 208 becomes 208. Again, x bar, x of I minus x bar. So 250 minus 358. So 358 and 250. Negative sign, 8, 0, and 108, so negative 108, positive 108. Then you have 350 minus 358, so that's positive 8. Then you have 450 minus 358. 450 minus 358, which is 90. Let's say, let's make this a 3, 15, 14, and 10. So that's a 2. 9 plus 5 is equal to 14. That's 92. 92. And then you have 550 minus 358. 550 minus 358 58. Again, you can write this as a 4, 14, and 10. That's a 2, that's a 9. 9 plus 5 is equal to 14, and 192. 192. And then again, you have, these are 100, basically, every time you're adding 100 to these numbers, so you have to add 100 to these numbers. 292, 392. So, so that's x, the absolute value of x of I minus x bar. Now, f of I times the absolute value of x of I minus x bar is equal to, basically, f of I is this column over here times this column. 4 times 308 is equal to 1200, and then you have 32, 1232. 8 times 208 is 1664. 8 times 8 is equal to 64. Is it? Am I right? 8 times 208, 1664. 9 times 108 is equal to 972. 10 times 8 is equal to 80. 7 times 92 is equal to 630 and 14, so that's 644. 644. 5 times 192 is 500. 5 times 9 is equal to 4, basically 5 times 9 is equal to 450. 5 times 100 is equal to 500, 5 times 9 is equal to 450, and 5 times 2 is equal to 10. So that's 960. 960. 960. 4 times 292 is 800, and then 360, and then 8, so that's 8, 6, and 11, 1168. 1168. And then you have 3 times 392, which is the same thing as 900. And then 3 times 9 is equal to 270. And then 3 times 2 is equal to 6. That's the 6, a 7, and 11, 1176. So you have all of these numbers. If you add them together, you will get, basically, you have to write them somehow properly. 1232, 1664, 972, 80, 644, 960, 1168, and 1176. So you have 2 plus 4 is equal to 6, 8, 12, 26, 2, 5, 11, 11 plus 7 is equal to 18, 18, so you have an 18 there. 12 plus 6 is equal to 12 plus 6 is equal to another 18, and you have a 13 there. That's a 36 plus 13, which is equal to 49. 4 there. That's a 6. 6 plus 6 is equal to 12. 12 plus 9 is equal to 21. 21 plus 6 is equal to 27. 36 and 38. The 3 over here. 5. 5 plus 2 is equal to 7. 7896. So sigma f of I times the absolute value of x of I minus x bar is equal to this number over here. Okay, is equal to this number there. 7896. 7896. And you know your sigma alpha by. Your sigma alpha by is equal to 50, so you'll get this as 7896 divided by 50, which you can calculate as divide by 2, you will get, I don't know, 3500. That is 400. That is a 45, 48. So that's an 8. That's a 4. That's a 9. That's a 3. 3948. Divide by 2, 3948. And that's a 25. And that's only divisible by 5, so you cannot simplify any further. And I hope that you can follow the way that, for example, I divide. For example, when I get some number like this and I want to divide by 2, what I do is that instead of writing, for example, 7896 divided by 2 and do the normal basically division, what I do is, for example, I think to myself that I have a 7,000. So 7,000 divided by 2 is 3,500. I have an 800. 800 divided by 2 is 400. I have a 90, so that's a 45. I have a 6, so that's half of that is 3. And then you can add all of those together. It's give you an 8, a 4, a 9, and a 3. 3948. 3948. Sometimes you can do calculation this way. Now, if you have 3948 divided by 25, you will get 1 times 25 is 25. So you get a 4, 1, 4, 3, 4, 5. 5 times 6. 6 times 20 is equal to 120. 115, or 5 times 5 times 1 is equal to 25, 2, 10, 125. So you get a 3 over here and a 14. So 14 minus 1 is equal to 9, 3, 1, and then 11, 8. And then you have 7, 8 times 160, 40, that's 207 times. 7 times is going to give you 35, 3, 14, 1775. And that is basically 3, 2. The decimal point here is 0. That gives me basically 9 times 250 is 180 and 45. So that's 5, 2, 225. That's 9 times. So 9 times 225. So they get 5 remainder. If I add a 0 over here, 2 times would be 50. So that's the same thing as 157.92. Okay, so that is basically that. Now, that's the mean deviation. About the mean is 157.92. Let me see if the answer is correct. Number 9. 157.92, exactly correct. So what that means is that, first of all, it's the mean deviation about the mean, meaning that, and your mean was 358. And this is income per day in rupees of a number of 50 people, right? So that means that in these 50 people, among these 50 people, everybody was basically earning on average 358 rupees. The unit of currency over here is rupees. On average, everybody was doing 358 rupees per day. And then on average, basically every person the income of every person was 157 rupees, either less than this amount or more than this amount, because on a number line you have 358, for example, as the average. 358 rupees, for example, on average, or the mean, which is the mean of your data, meaning that everybody was on average doing 358 rupees per day as the income. Now when you calculate the mean deviation about the mean, what that means is that basically there are all of these observations around the mean. For example, you go all the way up to 0 and go all the way up to 800. That means that you go all the way up to 800 here and you go all the way up to 0, for example, here. So that is like 400 units away from here. That is also like 400 units away from here, right? So, but now the way that all of these observations have been scattered around this mean basically is shown by this number, and it says that the way that all of those observations have been scattered around this mean is that the average of all of those, the average of the distances of all of those observations from this mean was 157.92, meaning that you can say that on average everybody was either around 200 rupees less than earning. At least everybody was on average, of course. Everybody was earning either 200 rupees, for example, or 160 rupees less than the mean, or less than 360 rupees, or all the way up to 160 rupees more than the mean on average. But of course there were all of these extremes as well, meaning that there were, of course, people who were, for example, earning next to nothing, or there were also people who were earning, for example, all the way up to 800 rupees per day. But then on average everybody was within 160 rupees of the mean, which was 360 rupees. So that's basically how you can make sense of this situation, right? 157. Okay. Now the next question that we have is question number 10, which is again the same kind of problem. Okay, so now let's do one more example, the same type of example. You have this data, which is basically you have the heights in centimeter, height of some people, height in centimeter of some people, and it's basically your data has been grouped into a few classes, 95 for example to 105, 105 to 115, 105 to 115, 115 to 125, 125 to 135. So 95 to 105 is 100, okay. 135 to 145, 145, and 145 to 155. And then these are the frequencies, so the number of boys that had these heights. So this is the frequency of those classes f of I, which is 9 and 13, which is 20 and 26, and 30 and 12 and 10. And so what you want to calculate here is the mean deviation about the mean. The mean deviation about the mean. About the mean is basically x bar, which is, as you know, is equal to the sigma of basically f of I times the absolute value of x of I minus x bar over sigma f of I. So I need to calculate my x bar first. Now, to calculate x bar, I can use basically either any of those three methods. Let's see how it goes. So if I want to use, for example, the first method, which is, for example, the direct method, I would need basically sigma f of I x of I over sigma f of I. So I need my x of I. And x of I is not present here, so I have to find the class marks. I need to find the class marks. To find the class marks, which will say basically which will serve us as the x of i's, you need to take the average of these two numbers. So 105 plus 95 is equal to 200. So the average of that would be 100. 115 plus 105 is equal to 220, I suppose. 115 plus 105, 0, 1, 2, 220. So that's 110, right? 110. Half of that is 110. So that's 195, 200, 100. Okay. So 115, 125. 0, 1, 4, 240, 120. Okay, 110, 120, 125, 135 is 250, 260, and 130. And the same thing keeps going on, 140 and 150. And I didn't want to erase that, but I did. That doesn't really matter. So now I need to find sigma. Basically the formula was sigma f of I x of I over sigma f of I. So f of I times x of I is basically well, the numbers are a bit large, so I'm going to basically take, for example, this number as the assumed mean of the data, and then write basically d of I as x of I minus a to make my x of i's a little bit smaller. So then, for example, 100 minus 120 is negative 20. 110 minus 120 is negative 10. 120 minus 120 is 0. 130, 120 is 10, 20, and 30. And, well, now we can calculate. There is no problem now. So I'm going to use the assumed mean method, which is x bar is equal to a plus basically sigma f of I d of I over sigma f of I over sigma f of I. So f of I times d of I, f of I times d of I now is equal to, this is d of I, this is f of I. So that's negative 180. That's 13. That's negative 130. That is 0. That's 300. That's 24, 240. And that's 300. And then sigma f of I d of I over here, f of I d of I is equal to basically 130 plus 180 is equal to 200, 310, negative 310, and over here you have 300. Cancel it out with this 300, you would get negative 10, and then you have another 240 plus 300, which is 540. That's 530, and meaning that if you add all of these numbers together, you will get 530. And so sigma f of I, which is basically this column over here, is equal to basically 22 plus 26, 22, 26, and that's 42, 52. 6 plus 4 is equal to 10, 1, and then you have 5 plus 5 is equal to 10, so that's 100. That is 100, so 5.3, I suppose, we get over here. So that means that we have the heights of 100 people, right? So your x bar is equal to A, which is 120, plus sigma f of I d of I, which is equal to 530 divided by 100. This is 5.3. So that's 120 plus 5.3, which is equal to 125.3. 125.3. So your your x bar is equal to 125.3. So now that I have found my mean, I can calculate, for example, x of the absolute value of x of I minus x bar, which is x of I is basically over here, and x bar is over here. So for example, 100 minus 125.3 is 125.3 minus 100 with a negative sign, so you get a 0.3 and then 5 and then 2, so that's 25.3, and then you have the negative sign as well. In the absolute value it becomes 25.3. 110 minus 125.3, you will basically have to subtract basically 10 from this number, because this number has grown by 10 units, right? So that's 15.3. 15.3. Again, it's growing larger, so that becomes minus 10, that's 5.3. Again, larger, that becomes a let me see. If you have 110 minus 125.3, if you have 110 minus 125.3, and if you take the absolute value of that, you can write that as basically 125.3 minus 110, and then that would give you 351. And that with a negative sign, of course. So that will give you the absolute value of 15.3, negative 15.3, of course, which is equal to 15.3. This is correct. Now, again, if you have the absolute value of, for example, 120, the absolute value of 120 minus 125.3, that will give you negative 5.3, which is 5.3, this number over here. If you have the absolute value of 130, the absolute value of 130 minus 125.3, you will get 4.7. You will get 4.7, and that's 4.7 for that. If you have 140 minus 125.3. So if it was 125, you would get a 15, so that's 14.7. 14.7. And then when you have a 150, you would get 24.7. So then now I can calculate f of I times this expression, f of I times the absolute value of x of I minus x bar, which is equal to basically this number times this number. So now we have basically, for example, 9 times 25.3, which is 25.3 times 9 with a decimal point, 27.2, 45, 47, 4, and 18, 22, 1 decimal point, 227.7. 227.7. 13 times 15.3, f of I times, basically this is 13 times 153 times 13 with the decimal point. You get 9, 15, 1, 3 and 4, 0 and 153, 9, 8, 9, 1, 1 decimal point, 198.9. 198.9. We get 26 point times 53. 53 times 26 with 1 decimal point, we get 18, 1. 31, 0 and 6 and 10. So you get 8, 7, 3, 1. And 137.8. You get 30 times 47. So the decimal point is cancelled out with the 0, so you can simplify this as 3 times 47. 47 times 3 is equal to 21, 2, 1214, 141. 141. 12 times 147. 147 times 12 with a decimal point. 14, 1, 8, 9, 2, 0, 147. This is a 9, so this is a 4. 16, 1, 7 and 1, 176.4. 176.4. And then you have and then you have 10 times 24.7 is 247. Now if you calculate sigma f of I times the absolute value of x of I minus x bar, you will get, well, you have to add all of these numbers together, 227.7, 198.9, 137.8, 141.0, 176.4, 247. Add all of them together, you'll get 16. 16 plus 12 is equal to 28. 28. 9 plus 8 is equal to 17. 17 plus, so you have 17 there. You have some 8 plus 6 is equal to 14. 14 plus 7 is equal to 21. So that's 38. 3 over here. And then you have 5 plus 9 is equal to 14, 17, 21, 21, and you have a 21 and 11, which is 32. You have 3 over here. 5, 6, 7, 8, 9, and 11. So you get basically this number over here, whatever that is. Okay. So sigma f of I times this whole thing is equal to 1128.8. and then you need to divide that by sigma alpha y, which is equal to 100, which will give you basically this decimal point moves back 2 decimal places. You will get 11.288. This doesn't make any sense. Well, it does, because you see, this is the mean deviation about the mean. Your mean was at 125.3. So this number is a fairly small number, well, at least compared to your mean, right? So what that means is that most of these observations have been very close to your mean, meaning that on average everybody was about 125.3 centimeters. Their height was about 125 centimeters, and everybody else was on average either 11 centimeters taller or 11 centimeters shorter, but everybody was about, well, 130, 140, not less or more than that, really. So that's basically that. That's number 10, 11.28. That is the correct answer. So now, through these examples, what you need to do is that you need to understand the concept here, right? And then what happens is that then when you go into your higher studies, for example, you get into, I don't know, electronics or physics, or for example, you get into physics, or even into mathematics itself, then you will be able, if you understand the concept here through these examples, then you will be able to use the concept in order to do, for example, other things in mathematics, in order to do other things in physics, in order to do, I don't know, other things in any branches of science, wherever you might go. But it's important to understand the concept, because if all that you learn is just a bunch of formulas and then put the numbers together, some people do that. I don't know how they do it. It seems, well, logically it doesn't seem to be possible, but some people actually do it. They can basically memorize formulas pretty well. I cannot do that. I cannot memorize formulas unless I understand the formula. In which case I have learned the formula, I haven't memorized it. But some people memorize formulas in a very, in surprisingly well, and then they even understand how to use the formula. And it seems to me that they don't really understand, they understand nothing about the concept, but still they can use the formula in some way, which is of course very surprising. But some people actually do this, which is, I really don't understand it, but anyway. So that's basically the concept here. Now in the next video we will talk about the next two questions, which is 11 and 12. So I'll see you in the next video.